Okay, so I'm Alex Gilady from Netflix.
Nicolas Levy from Qualabs.
And worked on the ABC Accelerator. And here is Piers from BBC. So we worked at the ABC Accelerator. And initially, we tried proving that L3D works. And then we started looking what happens when you have HTTP2 and HTTP3, and you add priorities to this. How does this affect low latency? So let's try seeing. So if, just in case if you fall asleep, we don't know for sure. We have a feeling what it should be like, and we need help trying to make statistically significant conclusions, and we'll see why. So first of all, why do we think that this matters? After all, HTTP is HTTP is HTTP. First of all, HTTP2 and 3 introduce multiplexing. So we're always working with a bunch of connections. You have video, you have audio, you have manifests. So here we are going and using a single TCP or QUIC in case of HTTP3 connection. So the next thing is priorities. Since we have multiplexed connection, we can prioritize certain requests over the others. Lastly, HTTP 1.1 has neither of these features, but there is an emulation for the POR fetch API where you can go and have something like, in case of Chrome, 6 connections and prioritize across 6 connections. And we'll talk about this later. First of all, 3 slides stolen from my friend Ali, because you cannot explain low latency better than that. So we talked about live at scale. Here is live at scale 1969. Moon landing, 650 million viewers, 3 seconds glass to glass, given that one of the glass is on the moon. Unless you believe the conspiracy theories, in which case it's less interesting. Now, 50 years of progress, and we have Super Bowl, and we have 45 seconds over 5 miles. And this is actually the norm. Going a little bit on a tangent, when people were switching to streaming from satellite, there were lots of complaints from people who got the modern streaming, and I learned a lot of really interesting English words that I never knew about reading the reviews. So, how can you go and get at least somewhat close to 1969 right now? So you have a concept of CMF chunks, or if you will, partial segments. The difference between the two is whether you request them individually or you request one segment and get it in pieces. In both cases, instead of sending a single GOP wrapped in a single file format box, you go and you send things in smaller packages. So let's say here we have a 2-second segment. We can go and send it, as we do right now, in one package. We can go and send every 3 samples. So that's less than 100 milliseconds. This will probably kill your CDN. If it won't, you will get and decode your first samples before the last sample of the segment is actually encoded. Now, why does this work? You may say, okay, you just pipelined transmission. Yeah, you gained almost 2 seconds. We have 45. Why does it matter? The key thing here is that a player buffer is a digit ring buffer. So you are trying to go and cope with best effort delivery. So as a result, you have more frequent deliveries. Your buffer is stabler. Your buffer is stabler. You can actually go and shorten it. And then the classic quote: there is no such thing as a free lunch. So the smaller the buffer, the brittler it is. Now, a quick detour. What are HTTP priorities? So initially, there were HTTP2 priorities. They were pretty interesting, never implemented, too complex. So HTTP3 priorities are pretty anti-intellectual. So it's just a header with two parameters, U, urgency or priority, and I, whether we can go and interleave requests. And again, a reminder, yes, we can do all of this, but still stuff can be brittle. Then the last thing, priority for the poor with HTTP 1.1, you can go and define different priorities, high, low, auto, and fetch priority is either mapped to the priorities we just discussed with you and I. It's different across browsers. In most cases, you do interleave. And for HTTP 1.1, you go and you mix 6 different connections in Chrome. And what was actually done?
Okay, thank you. So we moved on and said, okay, we have to try this. So we designed our experiment that was very, it was like a lot. We said, okay, we want to test with real users, choose CDNs, for example, Google Cloud Akamai, the 3 main browsers, Chrome, Safari, Firefox, that's all the low latency protocols, low latency HLS, Dash, L3D Dash that we just saw, 3 players, 3 versions of HTTP, the priority settings that we just saw from the Fetch API, and the type, what we wanted was dependent of the type of the object, we wanted to map, like to say, okay, manifest will be like high priority, and for example, init files in auto priority. And of course, to have a control group that to not set any priority or whatever, so we can check what happened. And as you can see, it's an explosion of combinations, so we have to be more realistic. And we decided to go just with 1 CDN, 1 browser, and 1 player that was Shaka player, and the rest keep as the same. So we made the setup. As I said, we use Shaka player. It implements the 3 streaming protocols we wanted. It also uses Fetch API for all the type of the request that this doesn't happen with other players. So this was good for our experiment. And also at that moment implemented a CMCD event mode draft that was super useful for us to capture all the data. So with the priority settings, we did a small change, a very, very small change into Shaka just to be able to pass this configuration to say, okay, all the manifest requests, for example, in high, video in low priority, audio in high, and so on. Then we created like a simple page that was like a script. The idea was we gave this page to all our friends from the community that it just chooses by random 1 combination of priority, saying, okay, manifest in high, video in high, audio in low priority, in auto priority, and in auto priority for in HTTP3 and with low latency dash, for example. So all the combinations by randomly and just play like 5 seconds of each video. And of course, we use as the request receive event, as we saw today in Wislaw presentation, and we captured like time to first byte, last byte, the object type, the media start delay, latency, the buffer starvation, and what we did is with the constant ID, we just send all the experiment, like, okay, my high video, HTTP protocol, streaming protocol, and the combination of priority settings. And also we wanted to also capture browser name, country code, and ASN or ISP, just to check where the request, the players were played. And to do that, we use an open source tool that we also created for the accelerator, that is the CMCD toolkit. It's a reference toolkit to deploy it in Google Cloud. With this, you can collect CMCD v2 event mode. It has the project has its own BigQuery schema and also has some optional configuration and modules you can add to enrich the data with geo data and user agent parsing. So if you want to know more about this, you can go to my tutorial on day 3, and I'm going to talk more about that project. And we asked a lot of people, a lot of you helped us to run the experiments, so thank you for that. So we could capture a lot of sessions from 10 different countries just using Chrome. And then we started to see the issues. So the first one, we found that the implementation at that moment in Shaka Player had some issues with the throughput of L3D Dash. So as you can see, it measured a very tiny throughput, and that's why we couldn't, the player couldn't change rendition. And so we discard almost all the tests of L3D Dash because of this issue we found. We reported to Shaka and say, and the maintainer said, yeah, there's a bug over there, so we have to fix it to run this test again. The second issue where we went through was the latency API of Shaka also. When we saw the data, we saw that the latency was very different, but when we were doing like visual comparison, we did this, like we configured the live sync target, that it's a configuration in Shaka, that you can say, I want the live to be in, for example, 3.84 seconds, 2 segments in our case. And we have there low latency HLS and low latency dash. And we saw that the video was practically in sync, but the API of the player was saying that there was 3 seconds difference. So we reported this, and yep, apparently it's an issue that we should have to figure out what's happening there. And so we cannot compare the latency of these two, yeah, of these two. And also we have some issues with the data size. So we started experiments and everything went good. And as you can see in the chart, the weekend, for some reason, we started to lose some sessions. So we cannot capture all the data we wanted. So at the end, we have like 47 sessions per each combination of protocols, priority, and all that. And that means like 4 sessions for each combination and country. So yeah, we need more data. Oops, sorry.
Another one. Okay. So as we said, we have a hunch, and we looked at 2 things: median and P75, rebuffering rate, and video start delay. Why 75 and not 95? 95 and 99 in case of 40-something sessions are exactly the same session, so it's meaningless. For low latency HLS, we saw that prioritization seemed to be essential for good performance, and HTTP 1.1 performs the worst, both in terms of rebuffering and in terms of video startup delay. In low latency dash, we saw that HTTP 3 has the benefit of least rebuffering delays. Prioritizing is interesting, so it has benefits, but more benefits from prioritizing both initialization segments and manifests. So this is easily explainable. You do want your initialization segment as fast as possible when you're switching rates. And something that right now I cannot explain is HTTP2 performs actually best. It performs stabler than HTTP3. So I don't know if it's a protocol thing, or it's a Chrome thing, or an interesting combination. And this brings us to our next step. We need more data. We want to have a meaningful P99 of at least dozens of sessions. Then we can say something that is called a conclusion. Plus, we need to have the issues in Shaka fixed to be able to rerun this. And we need to include -JS in the test, because we don't want inadvertently to include something that is specific to Shaka in this test. So then we need to make sure that Apple HLS provides us with apple-to-apple latency measurement. And we had a problem. The reason we had to use Fetch API was that in most cases, when you go and put manually the values of the priority and interleaving, you have an options request preceding the actual GET request. So this means that all of a sudden you are 4 RTTs instead of 2, which makes the continuation useless. So please join us and help settle this question once and for all the next few months. And thank you.
So very nice study, guys. Thanks. I'm interested in the outcome, but as you search for more data, I think we as a community need to be careful of using ourselves as the test subjects. We are not a random sample. Like, most people here are going to spend a lot of money buying a nice fat pipe to their house. So it's not really reflecting the audience, right? We need to have a better way to achieve the results. And you might be better off recording scenarios that are more representative of real audience, be cellular or lower end connections, and then replaying those in a lab environment versus immediately going to the real world and asking our peers to test it, because I don't think that's going to give you the diversity of input that genuinely reflects the world in which this needs to operate.
The only thing that, so first of all, you're right. Second, the only thing that we could do to go and try emulating the real world is running these tests in a number of different countries with completely different infrastructures. So we had France, we had Brazil, we had Uruguay, we had US. I think at some point we even had New Zealand. So that was something that was a mitigating factor. Same with varying distance from the nearest Google availability zone.
What server did you guys use for HTTP server? CDN? Yeah. No, but I mean, what was the server, actual server software?
It's whatever Google Media CDN uses.
Oh. I'm curious because 2 years ago when we wrote a paper on this, a lot of HTTP server implementations didn't implement priorities correctly. So this was a problem 2 years ago.
It's still a problem. Nginx doesn't do this, for instance.
Hi, my name is Mark. Following up on Will's comment, have you considered running these types of experiments on by joining Measurement Lab, the M Lab, where you can have your code running on the Measurement Lab servers plus your test clients that people like today when you go to Google and you type how fast how fast is my link, it takes you to Measurement Lab, so that maybe this way you could get people to contribute in a manner that's similar to what Will was positioning.
So that's actually super interesting, and maybe let's take it offline. I would be very glad to learn more about it.
Thank you. Yes, Daniel.
Thanks. Just one quick question. So, Piers, we talked about this before, but what needs to be modified in their shares? Is it just XHR that is causing problems? Do you only need Fetch API or other changes as well?
Yeah, well, because the current implementation of L3D uses XHR, doesn't it? So we needed Fetch to be able to provide the fetch priority that then the browsers then map that to a priority header that's signaled in all requests. So you'll see a priority header in most requests coming out from most browsers now. And the only way to influence that without, as Alex was saying, doing it yourself, you run into the sort of options request and stuff.
Okay, but that would be the only change. Otherwise,
yeah,
okay.
yeah. And I guess feels like Fetch API is more timely, so be useful for that in terms of getting faster responses, maybe.
So Piers, there's Fetch in mock. You know that, right?
Yep, I think that's a different API, though, isn't it?
Okay, my name's Keith. I'm from Nokia. From network perspective, have you guys tested simulate the network environment in different sort of conditions? For example, mobile network, home Wi-Fi network, Neo, MEO, or Geo?
We
or
haven't
hubs?
haven't really. Well, we didn't really do any network simulation. I mean, like we're saying, it's kind of preliminary results. So this is sort of a step on the way. And but I think what we were interested in more was the fact that, like Ali says, you've got priorities are like they're specified in the RFC, but the actual implementation that happens in commercial CDNs, that's kind of what we were more interested in than putting in our own specific implementation of priorities and then sort of saying, well, that's how that works. But what we wanted to do, we want to try real systems. So Cloudflare, for example, has deployed priority support in their CDN over the for the last 2-3 years. And well, other providers have mentioned, I mean, Google mentioned they have support, so we were interested to see how the Google networks would behave when we provide and signal priority.
Yeah, you haven't answered the question. Okay, my question is that what sort of loss can you sustain that without dripping off or stall or falling off the cliff? Have you tried to put 20, 30% or 50%?
No, I mean we haven't really done that. No, not yet.
That's basic fundamental things for all the streaming.
I mean, go for it.
So I think that if Nokia is interested in doing these tests, you guys probably have the best possible simulation.
Yeah,
So
I have it. I carry it in
again,
my handbag.
let's talk over drinks.
Okay.
They're getting closer and closer.
All right. One last thing, Pierce, what I want to comment on is that when you are playing with the priorities for different, requests, right? I mean, one of the goals is really to, for example, prioritize the clients that are asking for the lowest bitrate quality rather than the highest bitrate quality. That was one of the aspects that we actually looked into. So priority is, will it actually help the overall population of the streamers or just the highest or the best streamers out there, right? That sort of thing. So it's not really trying to optimize your own performance, but trying to optimize the overall performance of the all CDN customers and so on. So that's another angle to look at.
True, yeah. I mean, I guess the priority spec typically sort of is specified within a single connection. The priority kind of happens. So in that sense, it's sort of just traffic that you're seeing really. So you want to prioritize like manifests over media traffic because depending on what you're doing, but if you're doing HLS, then you kind of need to get the manifest fast. Otherwise, things aren't going to happen.
In the real world, there is hybrid solutions. Most of the customer users, at least, use 1.1. So any tests, any consideration to use some hybrid and to see how can we optimize that and do optimization on a hybrid solution until we get end-to-end HTTP3 or 2.
Yeah, I mean, then the thing is that the sort of the prioritization schemes aren't really specified for H11, partly because of the fact that you can't do connection coalescing over H11. So then the prioritization that you're doing, then how do you do that? Where are you? It then becomes more complex. It then becomes a sort of quality of service sort of approach. But the current RFC is really about just prioritizing within your connection and seeing how that can benefit. But yeah, I mean, we're trying to understand how it would work, or well, H11 is just comparing it to then H2 and H3 with the priorities.
Okay, actually we took all of your time, Pierce, for your next talk.
That's it, yeah, that's me done.